Empirical rule used to only come up on the ordinary level, but recently started showing on the higher level. So let's have a look. In an exam, the marks awarded to 30,000 candidates were normally distributed with a mean mark of 180 and a standard deviation of 55. The scale diagram below shows the distribution of marks on the exam. So the first thing, we have to fill in the 6 missing numbers in the diagram above. And it doesn't say specifically to use empirical rule. However, in part 2, it's saying use empirical rule. So it is about empirical rule. And by the way, that's how we can fill in those 6 missing values. There is no other way if not empirical rule. So where do we start? In the middle, mean is in the very middle. And how does it work? So if from mean, I will go in both directions plus a standard deviation and minus a standard deviation, right? So that's my first value. So in this case, 180 minus my standard deviation is 55 will be 125. And then 180 plus 55, that will give me 235. Now, what we need to know about standard deviation, that area, both plus standard deviation minus from the mean, that is 68% of all that area, of all that probability of all that population. That's what it means. And that's the difficulty with empirical rule, to remember the percentage, because it's not in our table. Then we go again. If we go to standard deviation, so from the mean, both direction, we go to standard deviation. So minus 1 minus second, and in the other direction, plus 1 plus second. So again, it's just a matter of putting it in the calculator, and standard deviation is 55. The value here we will be getting is 70, and on the other side, 290. Now, again, that area now, within 2 standard deviation of the mean, that is 95%. And now, last more time, third time. So now we go from the mean, 3 standard deviation in both directions. So on one side, we take away 3 times 55, and on the other side, we add up 3 times 55 from 180. And again, just a matter of putting it in the calculator. On the extreme end, we have 15 and 345. Now, that is actually not 100% yet, almost. That's my 99.7%. That's when I'm going within the 3 standard deviation. Okay, and then the second part. Use empirical rule, or otherwise, to find the number of candidates. So I'm looking for a number. My answer here will be a number, I don't know, 1,553 candidates who were awarded a mark between 70 and 235. So I brought those again so that we can mark it. So 70, and then 200, so that's 180, 235. And now how we're going to work that is that here, 2 standard deviation. So if it was going in both directions, that is, what did we say, 95%. But here we're only going to consider a half of it. So 95% multiplied by a half. On the other side, 1 standard deviation. So that means if it was on both sides, it will be 68%. But now we are only considering a half. Okay, so let's build our calculation. So from 95%, we take a half, so multiply by a half, and therefore plus. From 68%, again 0.68, again we take a half, so we multiply by a half. Together, when we add those values, we're going to get the area, the percentage expressed as decimal, isn't it? And then we are multiplying that by 30,000. And we put that in the calculator, and we get 24,450. And if you are wondering why did I change percentage to decimal, I could, as long as I put in my calculator percentage sign, it will work. But I cannot put that calculation without percentage sign, yeah? So I can do two versions. Either I change percentage to a decimal, or if I'm using percentage, I have to make sure I have that percentage sign in my calculator.